Hi viewers, here we will see the basic terminologies in the Bayes theorem. The Bayes theorem was created by Thomas Bayes, which is used to facilitate to work on complex data science problems. The Bayes provides thoughts in making the decisions based on probability theory. The Bayes theorem is used to calculate conditional probability for machine learning applications that includes the classification problems. The Bayes theorem is having some basic terminologies: experiment, sample space, event, random variable, exhaustive events, independent events, conditional probability, and marginal probability. So here we will see one by one. The experiment is defined as a planned operation that is carried out under controlled conditions. For example, tossing a coin, rolling a die, and drawing a card out of well shuffled pack of cards. Sample space, in the sense the result of an experiment, is called an outcome. The set of all possible outcomes of particular event is called sample space. For example, when you are throwing the dice, that is called experiment. In this throwing dice experiment, we will record the outcome. So there is the possibility of outcomes are when you are throwing the dice 1, 2, 3, 4, 5, 6. So there is the 6 possible outcomes. The collection of outcomes is called sample space. Event is defined as set of outcomes of an experiment. Subset of sample space. Event is called subset of sample space. So here, for example, when you are doing the experiment of throwing the dice, we will get two types of events. One is the possibility of getting odd numbers from the dice 1, 3, 5. That is one event. The event B is when you are throwing the dice, there is the possibility of getting uh, the uh, greater than 3, greater than 3, 4, 5, 6. So there is the three possibilities. Like that, suppose if you take event C, getting the possibility of even numbers when you are throwing the dice as an experiment, 2, 4, 6. So like this, there is the subset of sample space is called events. So here the probability of A is denoting the number of odd numbers getting from the possible sample space. So number of favorable outcomes divided by total number of possible outcomes. So here the number of events belonging to the number of outcomes belonging to the odd number is 3, 1 comma 3 comma 5 out of 6 possible outcomes, 1, 2, 3, 4, 5, 6. So you are getting 0.5 is the probability of event A. Like that, probability of event B. B is the event which is greater than the 3. So 3 by 6. 3 is 4, 5, 6. Then 6 is number of possible outcomes, 1, 2, 3, 4, 5, 6. So 0.5. The basic operation in set theory is union and intersection of the events. And a fourth basic terminology is random variable. The variable which is taking on random values, with each value will have some probability. The probability may be a 0 also. It is real valued function defined on the sample space of an experiment. Already we know the experiment is just we are doing the task. then from the experiment we will get this outcomes. The set of possible outcomes are sample space. For example, consider a random variable capital X on the sample space of a given experiment tossing a coin. It takes a value. We assume whenever you are getting the head, then we are representing +1. If you are getting the tail, we are representing with -1. Then the variable x takes the values either +1 or -1 with equal probability of 1 by 2. That means when you are tossing a coin, either you will get head or tail. So both are possible, equal possibilities, equal probability. That's why. So this is there is two events, head and tail, head and tail. So out of two events, there is a possibility of getting head also, there is a possibility of getting tail also. So half of the 50% of chance. So here the outcome is, expected outcome is head or tail. The random variable we are expecting +1 for +1 for head, -1 for tail, -1 for +1 for head, -1 for tail, right? The possibility of probability is 1 by 2. Exhaustive events is another terminology, a set of events said to be exhaustive if at least one of the events must occur at any time. So among the set of events, at least one of the events should be occurred at any time. So the two events A and B are said to be exhaustive if A union B is the sample space. A union B is the sample space. For example, in the sample space, we are having the head and tail. In this head and tail, so at least any one should be occur when you are tossing the coin. Like that, when you are having the throwing the dice is sample space 1, 2, 3, 4, 5, 6. When you are throwing the dice, at least you will get any one of this outcome, right? So here consider A is an event that a card is drawing out of the pack is red. So there is 52 cards in the pack. Then from that pack we are trying to drawing uh, red color card, but the red color cards are 26 available out of 52. So B is the event. B is the event in this 26 cards. In this B is the event that card drawn is black. So black is again the second event. So here this is also having 26 cards among the 52. So here A and B are exhaustive because the sample space is having both colors, red color cards and black color cards. So when you are drawing the card, there is the possibility of getting either red color card or black color card. Independent events is another term. If the occurrence of one event does not have any effect on the occurrence of another event, then the two events are said to be independent. If any event A is independent, that means not depending on another event B, then it is both are called independent events. So here the probability of A intersection B equal to probability of AB can be represented like AB. Then this is written as probability of A multiplied with probability of B. Consider if A is obtaining 5 when you are throwing the die, and B is drawing the king of hearts from well shuffled pack of cards. So here the A is related to the throwing the die, B is related to the cards. So both are independent. A and B are independent. Conditional probability in the sense the probability of an event A given that another event B that is already occurred. So here that is called conditional probability. That is one event is happened due to already another event which is already happened, so that is called conditional probability. which is denoted by probability of A given B. So we have to read this probability of A given B. So here the B is already occurred or already happened. So from this B, we are going to define A. We are going to define A, right? So this can be represented by probability of A given B, probability of A intersection B divided by probability of B. For example, the event A is denoting picking a card that is king from the pack of cards. From the pack of cards. In that king, that king is here, the event B denote the picking a black card, picking a black card. So here two events are there. First one is we are going to take the black card, we are going to take the king. In that king going to take the black card. Okay, black card. So here first we are taking the picking the black cards. In that black cards, the event A is representing the king. So here probability of A intersection B is probability of obtaining the black card that should be a king. So there is two kings available. One is the heart and sorry, one is the clever king is the black color and spade king is the black color. So two out of 52. So first probability of B is picking a black card, picking a black card. How many black cards are there? So there is 26 by 52. So it is called 1 by 2. So that is what given here. First we are picking the black cards from the pack of cards. So the 1 by 2. Then here from that 26, from this 26 we are going to this is the probability of B. Okay, so B is already happened. Now I am going to define probability of A. This is probability of A given B. So probability of A is picking a king from the 26 card, picking a king from this 26 card. Okay, so that one can be calculated by using the, so here that black king is two colors, two out of 52, two out of 52. So that can be calculated by using this formula, right? So probability of A intersection B divided by probability of B, then you will get the you will get the equation, you will get the answer from this equation 4 by 52. Then marginal probability is the probability of an event with A which is occurring independent of any other event B. So which is marginalizing the event B. So which is having a formula probability of A equal to probability of A given B multiplied with probability of B plus probability of A given negation B. Okay, not happened event B, right, and multiplied with probability of negation B. It can be represented in the form of probability of A intersection B plus probability of A intersection negation B. So which is from the conditional probability. So for example, the marginal probability, calculate the probability that random card drawn out of the pack is red. Okay, red color card is drawing from the pack of cards, that is event A. The answer is obviously 1 by 2 because there is 26 red color cards out of 52 cards. Then let's calculate the same through the marginal probability with event B which is drawing a king. So first what we have to do, we have to draw a red color cards, then two kings in the red suits, two kings in the red suits, one is the heart and another one is the diamond king. So out of that two, out of the 52 cards we are going to pick two cards, we are going to pick two cards. Remaining cards from the red suit is 24 divided by 52. So then we are applying the formula of marginal probability. One is the card which is drawing from the event B is already happened, then which is not happened, negation B. Okay, finally we are getting 1 by 2. With this, I conclude the session. Thanks for watching.